Okay, my friends, here's an application of Boyle's law. Um, we know that Boyle's law is going to be P1 V1 equals P2 V2, or we can call that the initial. Here's our initial right here. And then here on the right hand side of the equation is our final. Two different states. And we'll call that initial and final, or just first and second state. Okay, so let's read our problem here. We have this marine biologist going to do a dive, and they have this tank. Here is this tank that we need to fit all of this air in. And so here is this is how much we need. Here's our initial. This is what we need to breathe if we are up here on the earth and not deep down. That is the volume. But we need to fit this volume, this initial volume, into that final volume right there. Okay, well, this isn't a volume, but it's a tank, and we're told that it's spherical. So too bad we have to actually do a little bit of geometry calculations here. I do know that the formula for the volume of a sphere, so the volume equals 4/3 pi r cubed. Okay, so our initial volume is going to be this 2400, so I'm going to do P1. P1, our pressure on Earth is going to be 1 atmosphere. We're going to assume that that's the case. Our initial volume, the amount of air that we have to breathe, is 2400 liters. P2, the final pressure, that's what we're trying to find. And the volume for the second, what we're going to put into that tank, the volume for the second, is going to equal 4/3 pi r cubed. Okay, this shouldn't be too hard to figure out. It's kind of it's a little difficult understanding. We need to assume that the pressures be 1 atmosphere. That's not given in the problem. And V2 is also not given, but just a volume is the diameter of a sphere. Okay, so let's go ahead and put this in. So volume, let's figure out what that volume in equals. 4/3 pi. It's the radius, and I think they give us a diameter. Okay, so we're going to have to cut that in half. And the answer, if I can do that in my head, is going to be 32.5. So equals 32.5 centimeters. And that's going to be cubed. All right, so let's get out our calculator here. And I am going to put this in. 4 divided by 3 times 3.14, I'll just go out to that, times 32.5 times 32.5 times 32.5 equals, okay, the volume is going to equal 143.720.417. Okay, that's what I get for that volume. Okay, and that's going to be in units of centimeters cubed. Okay, so a centimeter cubed is a milliliter. All right, so I have to get either these liters into milliliters or these milliliters, centimeter cube is a milliliter, into liters. I think I'm going to go the liters route. Okay, so I'm going to take that answer that I got, and I am going to divide that by 1,000. And that's going to equal 143.720. Okay, this is my volume, my final volume, the volume in the second, and that's in units of liters. All right, let's put this information in now. We're going to solve for P2. So P2 equals P1 V1 over V2. It's going to equal 1 times 2400 liters, that's atmospheres, divided by 143.720 liters. All right, let's do that real quick. So I have 2400 divided by 143.72 equals, I get 16. So P2 equals 16.699 liters. And so with our sig figs, I've got 4 sig figs, I've got 3 sig figs. I need to have 3 sig figs. So P2 equals 16.7 liters. Okay, nothing too tricky. Things that can almost trip you up here is this is a pain, I know. Why don't you just give us volume? But that's a pain getting that into a volume just from the radius. Another thing that can trick you up is that's the diameter. Make sure you get that into the radius. Make sure you get your units the same. A centimeter cubed is a milliliter, but this is given to us in liters. So just a few tricky things to keep track of here. You can do it. I think it's a better explanation than AI could do. So do this yourself. Don't look at AI. Just get it done.